Okay, so hello future engineers and welcome once again to Mathematics in the Modern World. So the focus of discussion for this week is about the graph theory. So let's start by trying to define what is a graph. A graph is a collection of points called vertices or nodes and line segments or curves called edges that connect the vertices. So we are familiar with different types of the graphs such as bar graph, pie graph, and every graph that we have. But for this topic, we are going to focus on different types of graphs in this application. So graph construction is our next focus. So how are we going to do this? So let's start. Okay, example, you are given this table wherein there are a list of 11 cities connected with specific airline flights, which check symbol indicates what the cities of direct flight. So, anong kinanglan natin noon? We have to show a graph that represents this information, where each vertex represents the city and the edge represents the direct flight. Okay, so for our solution, we have represent lang ang mga cities sa vertex, like we have Manila, we have Tokyo, Taipei, Seoul, Hong Kong, Macau, Bangkok, Ho Chi Minh, Kuala Lumpur, Singapore, and Brunei. Then we have sa vertex. Tapos lang, simple lang. Tanawin mo lang connecting flights. From Manila, meron going to Tokyo. So we have Manila to Tokyo. We have Manila to Seoul, Manila to Taipei. So connect mo lang sila with a line. That's how simple it is. Same also with halin sa Tokyo. Anong connected sa Tokyo? Tokyo is connected to Manila. Okay, you know that. Tokyo is connected to Seoul. Tokyo is connected to Taipei. So that is just how simple a graph of representation of a table kung amo ni siyang type of graph. So that's it for a simple example of making a graph. Okay, so here are important definitions and concepts nga kinahanglan maintindihan in order to better understand sa graph theory. So first, we have a loop. A loop is an edge connecting a vertex to itself. So makita ta na karon sa example kung ano itsura sa loop. If two vertices are connected by more than one edge, these edges are called as multiple edges. A graph with no loops and no multiple edges are called a simple graph. So wala loop, wala ka multiple edge, simple graph. Next, path. A path is an alternating sequence of vertices and edges. So may edge ka, may vertex, edge, vertex. A graph is connected if there is a path connecting all the vertices. So connected sila tanan kung may path nga nag-agi sa tanan ng mga vertex. If the path begins and ends with the same vertex, it is a closed path or a circuit or cycle. So nag-start ka and end with the same vertex, so ang tawag silang siya ay circuit or cycle. Two vertices are adjacent if there are an edge joining them. So adjacent sila kung may tumira sa isa ka side or edge nga na-join sa duwa ka vertex. So they are adjacent. In every pair of vertices of the graph, if every pair of the vertices of the graph are adjacent, the graph is complete. Next, the degree of the vertices is the number of vertices attached to it. So, kung pila ka vertex ang nag-connect sa isa ka vertex, that is their degree. So, buti rin kung pila ka edge ang connected sa iya, that is the degree of the certain nga vertex. So now we will have examples of the graph. So for example, sa first nga graph, we have a null graph. Null graph siya kay may ara ka lang vertex and then wala ka connection. So null graph. Next example of a simple graph is simple graph since wala ka loop and then wala ka multiple nga edges. So simple graph na siya. This time, for third nga example, may ara kita loop. So paano mahaba nga loop? If It starts with that vertex and end with the same vertex. Wala siyang ginagyan ng iban, kundi nagtiyog lang din siya and then nag-go back siya sa sinanga vertex. Next, multiple edges. Nung makita multiple edges, duwa ka vertex, then may ara ka duwa ka line or duwa ka edge nga naga-join kina. That is a multiple edge or multiple edges. Next, connected graph. Kung bakit connected graph, dapat ang tanan nga ni mga vertices may ara gid edges nga naga-connect sila. So, may ara kita line connecting them. So, this is connected graph. This connected graph ka, kung may ara ka gap between the vertices, may ara mga vertices na wala na join. So, for example, in this part, may ara siya nga wala connection. So, this is a disconnected graph. Then, makahamba ka nga ang imong graph is not any more simple na graph. Kung may ara ka multiple edges, may ara ka pagid loop. So, pareho sa nga rin sang duwa. Nga rin diri sa right side sa aton nga presentation, they are not simple graphs. Kaya meron kita loop at the same time meron kita multiple edges. So, now we have complete na graph. A connected graph in which every possible graph is drawn between vertices. It should not contain multiple edges. So, wala multiple edges, then every possible edge is drawn between vertices. So, complete na siya ng graph. So, ano yung mga different examples ng mga graph? So, first, figure 1, we have wala edge lang siya. For figure 2, we have dua ka vertices. So, figure 1, I mean, is a vertex lang siya. Figure 2, meron ka dua ka vertex join sila sa isa ka edge. Figure 3, so meron ka tatlo. Then, meron ka man tatlo ka edges. Same with figure 4 and figure 5. Okay, so based on the figure, based on the different graphs na nakita natin, we could identify kung pilang edge and at the same time the degree of the vertex sa specific nga graph. So we have, for example, for K1, figure 1, we have, so wala siya edge, kay wala sang line nga nagka-connect between two vertices, so wala siya edge. So the degree of the vertex is also 0. Next, may ara kita, number K2 or figure 2, edge, may isa kita ka line, so we have one edge, and ang nagka-connect between kada vertex is isa lamang ka line. So that is the degree of vertex is also 1. Next, for the third figure, we have pila tanan ka line. So we have tatlo ka lines, tatlo siya tanan ka edges. Then the degree of the vertex is pila nagka-connect sa kada vertex. Sa kada vertex, for example, we have sa inyo vertex, pila nagka-connect sa iyang line. So we have may duwa ka nagka-connect nga vertex, so the degree of the vertex is 2. So for the fourth nga figure, so we have pila tanan ka edge, isipon mo lang 1, 2, 3, 4, 5, 6 tanan ka edge. So we have the degree of the vertex is, or the edges is 6. Then the degree of the vertex, tanawon mo kung pila nagka-connect sa kada vertex. Pila ka lang nagka-connect sa kada vertex. So we have 1, we have 2, and we have 3. So we have the degree of the vertex is 3. Same also with number 5, edges naton is. So, ang figure 4, duwa na siyang representation. So, for figure 5, we have pila tanan ka edges. So, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Meron kita 10 ka edges. So, we have E is equal to 10. Degree of the vertex is pila ang nagka-connect na line sa kada vertex. So, we have 1, we have 2, we have 3, and we have 4. So, the degree of the vertex is 4. However, meron kita simple na relationship between edges and vertex. Pwede natin sila magamitan sa formula nga nag-relate sa ilang duwa. Kung nabalaan mo ang either sa duwa. So, we have E sub n, kung depende kung sila ka-vertex, ka-edges, 1/2, n times n minus 1 wherein ang n represents ang imo nga edges. For n, which is greater than or equal to 3. So, may limitation siya. Dapat ang imo n should be greater than or equal to 3. Okay, now we have Euler path and circuit. Okay, so what is a Euler circuit? A Euler circuit is a closed path that uses every edge but never uses the same edge twice. The path may cross through vertices more than once. So, kung tanawan naton, by definition, simple lang din ang mag-determine ka sa Euler circuit. So, paris lang sa ginahimo natin, wala nga mga games, kamera ka mga dots, and then i-connect mo sila, dapat ka isa ka lang dapat mag-linya, hindi ka dapat mag-sulit. So, that is a Euler circuit. So, take note kung ano ang pares ng Euler circuit sa dalong. We have Eulerian graph theorem. A connected graph is Eulerian if and only if every vertex of the graph is of even degree. So, dapat, kung tanawon natin, ang degrees ng kada vertex, dapat tanan din yung vertex na gina-consider diri. Dapat tanan yung vertex should be of even degree. So, example, determine whether the graph is Eulerian. If it is, find the Euler circuit. If it is not, explain why. So, kung tanawan natin ng figure, so, those same lang man, same ang itsura sa tanan ng vertex. So, wala man may naglain na vertex. So, pwede na natin mahambang do regular, siya do regular polygon kung sa geometry. So, pwede na natin nga lantawan ng isa lang ka-vertex. So, sila ang degrees ng kada vertex. So, mula na kinanglan mo himuon to determine if it is Eulerian or not. So, for the solution, so we have the degree of each of the vertices is 4. So, kung isipon natin, meron kita 1, 2, 3, and we have 4 sa kada vertex. So, automatic, the graph is Eulerian. Kaya even ang aton nga degree. The path, and take note of sang ginubutang ko dari nga path nila. But pwede ka man ka-start sa ibang vertex and pwede mo man siya pang mahimo. So we have, for example, you start from A, D, B, E, C, A, E, D, C, B, A. Ang ina nga line starts and ends with vertex A. Hence, this is a circuit. Moreover, it uses all the edges once. Hence, it is a Euler circuit. So, ang condition para ma-consider mo siyang circuit is dapat ma-start siya and end with the same vertex. So, nahimo na natin so that is a circuit. Moreover, ang aton nga ma-form linya dayon is kaisa lang siya mag-agi sa kada edge. Subot silingon that is considered also nga Euler circuit siya. Next one, we have the Euler path. Euler path, a path that uses every edge in the graph exactly once, but it does not start and end with the same vertex. So, ang mula ng kinalain sa Euler path kay Euler circuit. So, ang Euler circuit starts and ends with the same vertex. Euler path, makompleto naman maagyan yung tanan ng edges, pero wala siya start and end with the same vertex. Next, Eulerian path theorem. So, ang pares kagina sa Euler circuit is Euler graph theorem. Subong naman niya Euler path theorem. So, a connected graph contains a Euler path if and only if the graph has two vertices of odd degrees with all other vertices of even degrees. Furthermore, every Euler path must start at one vertex of odd degree and end at the other. So, it must start sa one of the vertices nga may odd degrees. So, kag ma-end siya dapat sa isa naman ka edge, ay sa isa ka vertex nga odd man siya pa ng degree. So, take note of the Euler path theorem. So, para ma-determine mo kung may based on Euler path theorem, dapat may duwa ka edge nga a degrees, then ang tanan dayon nga edges is even ang degree. Then, it should start sa imong a degree nga vertex, sa isa ka a degree, then ma-end siya sa isa naman ka a degree luwat. So, for example, determine whether the graph is Eulerian. If it is, find the Eulerian circuit. If it is not, can you find the Euler path? So, paano natin siya i-determine? So, take note, using Eulerian graph theorem. So, take note na gingamit din ng theorem to identify kung Eulerian siya or hindi is Eulerian graph theorem. So, ano gina-state sa Eulerian graph theorem? Eulerian graph theorem states that para mangin Eulerian siya, dapat tanan-tanan mga edge, vertex should be of even degree. So, if we are going to look at the vertices, so our vertex A naton, kag vertex J is of a degree. So, both silingon, the graph is not a Eulerian. However, pwede natin mapangitaan pagi kay may ara kita duwa ka nga vertices basing sa Eulerian path theorem. Eulerian path theorem naman niya, dapat may ara ka duwa ka vertices. So, na-satisfy tanan may ara ka duwa ka vertices. If we are going to check sa iban nga mga edges, we will find out na ang tanan ng mga edges nga iban magluwa sa A kag J are of even vertices. So, na-satisfy naton ang gusto nga kondisyon sa aton nga Eulerian path theorem. So, buti lingon makakita kita sa path nga nag-start sa add nga edge, then ay sa add nga vertex, dun ma-end kita dapat sa isa pagid ka add nga vertex. So, one example is stated here kung paano natin himuon without duplication ang mga edges. Pero pwede ka man ka-start. Pwede ka man ka-obra and ka-trace ang lain man niya pa. So, for example, we have, halin kita sa A, B, C, D, E, F, G, H, I, J. Then, we are going to trace this one. So, take note nga nag-start kita sa A and nag-end kita sa J. Then, wala kita sa may duplicate nga side. So, nag-agi lang kita sa kada edge, kaisa lang. Then, pwede natin makonclude that the graph contains a Euler path. Furthermore, note that the path starts at A but ends at J. The vertices having odd degrees. So, take note everyone, isa pa lang sa mga graph na kinang natin matunaan. So, we have another type of graph which is Hamiltonian graph and circuits also nga related mo sa sininga topic. So, for this discussion, that's it for now. So, thank you everyone. Stay safe and God bless.